Hey guys, in this lesson we're going to talk about how do we represent sinusoidal functions. Our key concepts are the equation of a sinusoidal function can be determined given its graph or a description of its properties. So we're going to come up with the equations in this lesson. Transformations can be used to adjust the basic sine and cosine functions to match given period, phase shift, intercepts, amplitude, vertical shift, and range. So basically what that's saying is you can write the equation as a sine function or you can write it as a cosine function. It just depends on what you do with your phase shifts and your amplitude and whatnot. The graph of y equals sine x is a horizontal translation of y equals cos x. So like if you graph them on the same graph, you realize that you can just pick one up and move it, give it a phase shift, and it will be the same thing. So I wanted you to see for yourself using Desmos. This is an activity you can do for yourself. Just go in and graph y equals sine x and then graph y equals cos x minus 90. And then also go in and graph cos x and this one, and you'll see what happens. If you did that, hopefully you did it. I'm not going to do it for you guys, but hopefully you did it. You should see that they give the same graph. So you realize that they are just, they're the same graph, but they're represented different ways. One is represented as cos and one is represented as sine. So we can do that with any sinusoidal function. So what happens is some people tend to just like writing them as sine functions, which is something that I like to do. But notice that you can do the same thing. You can take a cosine function and change it into a sine one just by changing the phase shift and some of the numbers in it. Here's what we're going to do in our example. Write an equation of the form y equals a sine k x minus d plus c that represents the graph of y equals sine x after it has been. Now, here's what's going to happen. I'm going to highlight it. It's reflected in the x-axis, so we know it has a minus on the amplitude. Vertically stretched by a factor of 4. Horizontally compressed by a factor of 1/3, shifted 45 to the right, and translated 5 units up. So let's look at it. What I like to do is kind of write the stuff down. So we know it's reflected in the y-axis. So our A we know is negative. And it's vertically stretched by a factor of 4. So A is negative 4. That is our amplitude. Horizontally compressed by a factor of 1/3. So that means that K is 3 because we're going to make our period smaller. 360 divided by 3 makes it 120, so it makes it smaller. Shifted 45 to the right. So that means D is 45 to the right, so it's minus 45 degrees in there. And then C is translated 5 units up, so C is plus 5. And then all you have to do is sub those values in to write the equation. So the equation equals y equals negative 4 sine 1/3 x minus 45 plus 5. That's how you do it, and that's how it goes. Not too hard. You're just taking those numbers and values that you know and putting it into an equation. So that's it for this lesson, and I'll see you in the next one.